All right, all, welcome to video two. We're going to talk a little bit about cannabis and addiction here. First, I'm going to talk about endocannabinoids and the endogenous reward system, and then we're going to look at some self-administration data for THC and CBD. There's a lot of different self-administration studies that I could have looked at. I chose one that was very recent, it just came out in 2020, and it looks specifically at an inhalation chamber because, that's the way most humans take it. So I thought that I think that is the most relevant. All right, so there is some evidence to suggest that maladaptive reward seeking, which could result in something like addiction, right, or impulsive choices that have bad consequences, like we might see in people with ADHD. That's sort of common, especially in adolescents, and when they're really young, they have a little bit more trouble regulating their decision making to weigh long-term consequences. So there is evidence that this maladaptive reward seeking is linked to dysregulated endocannabinoid signaling. So it could be due to genetic factors. It could also be due to previous drug use and exposure. So when I say previous drug use and exposure, this could refer to prenatal exposure. This could refer to your mother using while you're in the womb. That's prenatal. It could also refer to drug exposure in adolescence. And while cannabis is not really more of a gateway drug than alcohol or nicotine, drug use of any kind, including cannabis or alcohol or nicotine when you're younger, so like the age of 12 or 15, significantly increases the probability that you will go on to move to use quote unquote harder drugs such as amphetamines or methamphetamines or cocaine or opioids later on in life. And if you want to see some summaries of that data, you can look at the NIDA summary of marijuana. That's what it's posted on Brightspace. They do a good overview of all of the sort of current marijuana research that's going on. So one of the genetic factors that could be driving this maladaptive reward seeking is a missense mutation in FAAH, which, if you remember, is one of the degradation enzymes for anandamide. Okay. Just this circuit right here, this is a circuit, it's a little bit more complex than the circuit we talked about with addiction, but all of these areas, the prefrontal cortex should seem familiar, the nucleus accumbens, the VTA, the hippocampus, this is the basolateral amygdala and the central amygdala. All of these should sound fairly familiar. And all of, glutamate and GABA and dopamine and cortico releasing factor. So that's that whole HPA access part that we talked about. This is what we think of as an addiction circuit. All these brain regions are involved in driving addiction. Endocannabinoids also have a high expression in all of these areas, and you see fairly high levels of the CB1 receptor in all of these, especially the globus pallidus and the dorsal striatum, which is part of the motor system. And just as a note, rodents actually have a much higher expression of CB1 in these motor areas than humans do. Okay. So cannabinoids can affect dopamine's increase in response to cocaine. So if we're measuring the change of dopamine in the nucleus accumbens and you give an animal cocaine, you see a big jump. If you combine that cocaine with a pre-treatment of rimonabant, which remember is that CB1 antagonist, that increase that you see in dopamine actually is not there. So there is something about CB1 receptors that is required to get that large response in dopamine. So what does this mean if you combine exogenous cannabinoids and drugs? It's very possible that by making that combination, instead of blocking CB1's response, you're heightening it, which could mean that when you combine endocannabinoids with other reinforcers, not just drugs, but any reinforcer, including things like food, like we saw in the last video, you could see a much stronger response from the dopamine system. Okay? So it can also affect the dopamine increase in response to alcohol. So this is a very similar experiment to one I just described. Well, the reason I want to point out is that weed and alcohol is a really common combination. So there could be something, if you are commonly pairing the two, you might find alcohol more reinforcing than other people who only use alcohol on its own. So here's a paper I want to talk about. Again, there are tons of self-administration papers that we could look at with endocannabinoids. I really wanted to find one that paired a THC self-administration with a negative effect, like a foot shock, like the ones we looked at when we first talked about self-administration. I think that that is important because it helps us sort of weigh how much negative consequence animals are willing to put up with in order to have the substance. And I think that's important for sort of trying to make parallels to our addiction criteria where someone is choosing to continue to use the substance despite a significant negative side effects. This is the inhalation chamber. So it looks a lot like the self-administration chamber that we've had before, except for instead of having drug infused straight into their jugular vein, which is how usually self-administration occurs, they just get a big puff of smoke right in the face. So if you want to know more about the setup and how it works, you can read the paper. But they're looking at vaporized cannabis extracts here. So they're looking at both CBD oil and THC oil. Right? So we have a vehicle. We have cannabis extract that's mostly THC. There's cannabis extracts using mostly CBD. The filled shapes are active levers, and the empty shapes are inactive levers, meaning they're there and they're available to press, but the animals don't get anything when they press them. And these are different reinforcement schedules. So FR1 means that they press the lever or do a nose poke once and they get 1 infusion. FR2 means you have to poke twice to get an infusion. FR4 is you have to poke 4 times to get an infusion. So as you can see, there's really no difference when it's FR1. They will take most of these things, including vehicles. When you leave an animal alone in a chamber, they're more likely to interact with stuff than anything. But as you require more and more work in order to achieve the response, you are more likely to see animals taking infusions of THC over CBD or vehicle, right? So this is the mean responses, so how many times they're responding, right? And so it makes sense that you have more responses as you have a higher requirement for how many. But this increase is really seen a lot more in THC than you see here. So even though you're required to make more responses to get these infusions, it's not in like these amount of responses are not increasing at the same rate as we see for THC. You're looking at vapor deliveries, which is basically how much drug how often they're taking the drug. They get significantly higher amounts of vapor deliveries for THC, and that sort of remains fairly steady across this reinforcement schedule. So if you make them work once, if you make them work 4 times, it doesn't really matter to them. They'll continue to take a similar level of infusion. Right. So the next thing that we're looking at is a progressive ratio. So progressive ratio means that each time you press, the next time you'll have to press even more to get an infusion. So this is where we can get that breakpoint figure, basically how many times will they press in order to get it. So each one of these circles is an individual animal, and then the bar is the average. So as you can see, THC has a significantly higher breakpoint than vehicle or CBD. This CBD figure looks significantly larger to me than this vehicle, but the paper says that it's not statistically significant, so we have to stick with that. Sorry. So as you can see, over time, so this is over time, not over multiple sessions, but they take THC animals will make more and more and more responses, which makes sense because over time it's a cumulative response, so they're just adding. And you see that with CBD as well, but not to the same degree as they do with THC. So animals will work for THC and they'll work harder than they will for CBD or vehicle. So this supports the idea that THC is reinforcing. It doesn't necessarily mean that it's addictive, but it does mean that it's reinforcing, right? So now that we're here, I'm just going to wrap this up here. A lot of people ask me about whether or not CBD and the claims of CBD could be substantiated, and I would love to look at that, but CBD is currently being investigated in 82 separate clinical trials that address all of these different disorders. So autism, epilepsy, Alzheimer's, Parkinson's, chronic pain, especially cancer pain, opioid addiction, antipsychosis as a treatment for schizophrenia or a supplemental treatment for schizophrenia, Crohn's disease, Huntington's, multiple sclerosis. It's also being looked at as a possible treatment for cannabis use disorder, basically people who are quote unquote addicted to cannabis, meaning they're continuing to use it even though there's negative consequences, and there are those people around, possibly driven by more about withdrawal effects, like I talked about in the last lecture on cannabis, right? So if you want to hear more about one of these in particular, I'm happy to talk about it, but I couldn't get into any of these all that easily, and I couldn't really pick one very quickly. I think I've heard the most anecdotal evidence for epilepsy, chronic pain, and anxiety, but there weren't any current clinical trials that I found on clinicaltrials.gov that specifically talked about CBD and anxiety. The side effects that I saw for CBD were mostly fatigue and headache and nausea, which is basically side effects that you see for literally every medication that goes into a clinical trial. So I don't think it can hurt, it most likely, but it's most likely, if I had to make a prediction, I would say that it will become a tool that the medical profession uses as either an enhancement or an addition to drugs that are already being used, or as something to try when nothing else has, like treatment-resistant epilepsy. So I'm sorry, you probably wanted to hear a little bit more about CBD than that, but if there's something specific you want to hear about, shoot me an email, put it up on the discussion board, and I can make a separate video about that particular topic. But CBD is definitely under investigation. We cannot make any substantial claims about what it can and cannot do at this point. We don't have enough longitudinal data to say whether or not it's safe. If you know somebody who's using CBD and they find that it has helped them, they're not having negative side effects, then the likelihood of it being dangerous seems to be quite low from what I've read and the data that I've seen, but there's no guarantee that it's actually having a real effect beyond the placebo effect. So that is cannabis and addiction and a little bit about CBD. The next video is going to talk about cannabis and psychosis.